Alright, so I think I'm recording. Let's take a look at problems that were rational expressions. When you have a ratio, you have variables in the numerator and denominator, and we're either multiplying two fractions together or dividing two fractions. Now, before I jump in and start doing this, I want to point out something that occurs that's very common when we have these fractions. We all know that if the numerator and the denominator have the same number, that 5 divided by 5 is just the number 1. Now, if we have an algebra problem where we have a variable, if we have an x divided by an x, it's the same idea that x divided by x is 1. And we commonly say they cancel. You might have a binomial like x plus 1 divided by x plus 1, and we do not cancel the individual terms. We look at this number that's in the numerator and recognize it's the same number in the denominator, and x plus 1 divided by x plus 1 is equal to 1. It reduces to 1. We say that those cancel. And even if we have three terms, as long as the three terms are the same, then the addition of these three numbers is the same, and we say that this entire number divides by that number, and that's equal to 1. And sometimes they'll just try to disguise that a little bit. They'll give you x squared plus 2x plus 1, and they might write the denominator as 1 plus 2x plus x squared. Because addition can be rewritten in any order, we can change the order of this addition to be the same as the numerator. And so if they shuffle this around, these still are going to cancel, and we get 1. Now, what students sometimes don't recognize right off the bat, let's take a look at a number like 3 minus, well, let's make it a little bit bigger. Let's make it 10 minus 3. 10 minus 3 we know to be 7. Now, what about 3 minus 10? It's not equal to 7, but it's equal to the opposite of 7, negative 7. What we did is we changed the order of the subtraction. So if you have a positive 7 divided by a negative 7, that's equal to negative 1. Or if you had the negative in the numerator and the positive 7 in the denominator, it still is negative 1. Well, what if they wrote 7 as 10 minus 3? And what if we wrote negative 7 as 3 minus 10? Well, we can see that these numbers divide to give us a negative 1. Because we know that 10 minus 3 is 7, that 3 minus 10 is negative 7. So in algebra, when you have variables, sometimes you'll have 1 minus x, and then the order of the subtraction will change, and you'll have 1 minus x. And we know that if it were x minus 1 over x minus 1, that would divide, that these would cancel, and it's a positive 1. But here, we can quickly say, well, this is a negative 1. And the reason, some people might teach you that when you have this 1 minus x, that you can rewrite this 1 minus x as, factor out a negative 1, well, you need a positive 1 there, negative 1 times the negative 1, and hey, that negative, that's taken care of there, so you have x, and like we say, we can rewrite this as x minus 1, and that negative 1, well, negative 1 plus x is the same thing as x minus 1. Now, to me, this could cause some confusion. You might make a silly mistake in doing that. I think it's easier to just recognize that when you change the order of the subtraction, that they cancel, but not to positive 1, but to negative 1. And we're going to see that in a couple of these problems where you have the opposite, where you have maybe a 2x minus 1 and a 1 minus 2x. And if you're dividing those, then these divide because they're opposites to negative 1. Alright, so I hope that helps. Let's see if it does help. Let's jump in and start doing some of these problems. Now, in the first 6 or 8 problems, it's multiplication of two fractions. We can multiply straight across the numerator and straight across in the denominator. That's what you do with multiplication of fractions. Much easier than addition of fractions. But before I jump in and start multiplying and getting large numbers and then try to reduce the fraction, why not look to see if some things reduce right now to make that multiplication a little bit easier. I see that 8 divided by 8 is 1. And I see that x divided by x is 1. So in the numerator, I have 1 times 2 times 1, which is just 2. And in the denominator, I have 10 times x squared. 10 times x squared. But we know that we can rewrite the number 10 as 2 times 5. 2 times 5. And so we can reduce this 2 divided by 2 as 1. So in the numerator, I have a 1. And in the denominator, I have 1 times 5x squared, which is just 5x squared. So there's my final answer for problem number 1, and I have the answer key on here that we can come in and check our answers. So hey, we have the first one correct. In the second one, we know that we're going to multiply straight across the numerator and straight across the denominator. So if we do that, we have 2 times 3 is 6, and x to the first times x to the third is x to the fourth. And 4 times 7 is 28. Well, I notice that I can reduce this, that I have two even numbers. Even numbers are divisible by 2. I can write 6 as 2 times 3, and I can write 28 as 2 times 14, and I can see that 2 divided by 2 gives me 1. And 1 times 3x to the fourth is 3x to the fourth. 1 times 14 is 14. Now, some people may have recognized, hey, I prefer to come over here with this 2 over 4 and say that 2 goes into there once and into there twice, and 2 times 7 is 4. That's fine. If you can do that, that's fine. If you don't recognize it, there's no worry, because you can look at your final answer here, or what you thought might be your final answer, and recognize that you can reduce it a little bit further. 3x to the fourth over 14, let's go check and see if that's correct. 3x to the fourth over 14, so we've got number 2 right. We're on a roll. Now we've got a little bit more things that are more complicated here. I'm going to put parentheses around this and parentheses around this, and just say that, hey, when I recognize these, when I multiply these numerators together, that's just the numerator of a single fraction, and in the denominator. So now let's look and see if anything cancels here. Well, at first glance you might think that it doesn't. 5 minus x and x minus 5 are not the same thing. They do not cancel to positive 1. But from our discussion at the beginning of this video, these are opposites. We've changed the order of subtraction. X minus 5 and 5 minus x are equal and opposite. They do cancel each other. They divide to negative 1, not positive 1. Okay? So the same over here. This 5 minus x divided by x minus 5 divides to negative 1, not positive 1. So now we can multiply these numerators together. The negative 1 times negative 1 is positive 1 times this 4 plus x And in the denominator, 1 times 1 is 1 times this x plus 3. Now I believe that that's how they have the final answer written. Some students are going to write that numerator in a standard form with the variable first. That's what I would probably normally do. And x plus 3. But either one of these is an acceptable answer. They're both, addition is commutative. The order that you add things together doesn't matter. So 4 plus x is the same thing as x plus 4. So let's go and check our number 3 and see if our answer key agrees with us. 4 plus x over x plus 3. They didn't change that order, but that's fine. Alright, so let's take a look here. Again, we have multiplication, so we just multiply straight across the numerator and straight across the denominator. So I'll put parentheses around this, and I like to do that for multiplication. And 8 plus x and x plus 8 are the same thing. They divide to 1. This and this divide to 1. 2 minus x and x minus 2 are not the same thing, but they are equal and opposite. They do divide to negative 1. Alright, now we can multiply it together now, or we can recognize, hey, this x divided by x, we can still reduce. X divided by x is 1, and 16 divided by 4 is 4. So wow, this really reduced. In the numerator, we have these 4 numbers to multiply together, which is a pretty easy multiplication. With this negative sign, our answer is going to be negative, and with the 1s times the 4, it's going to be a negative 4. And in the denominator, all these 1s being multiplied together, we're not adding them, we're multiplying them. And normally we write negative 4 divided by 1 is just negative 4. Let's check our answer for problem 4 and see if it's negative 4. And it is. Alright, so far so good. Now, here it's getting a little more complicated. We have a binomial here times another binomial, and in the denominator we have a trinomial times a binomial. I'm just going to multiply straight across, so I'm going to write these two fractions as a single fraction if I multiply the numerators and denominators together. So I'm going to start with this trinomial and do my x method, because I need to see this in factored form. So, because I'm hoping that when I factor everything, and that I'll have common factors and that this fraction reduces. The middle term here is negative 4x. The top of my x is the first term times the last term, which is negative 45x squared. Two numbers that multiply together to give me negative 45, but add together to give me negative 4. So I might have to do some trial and error here. I know since the bottom number there is negative, I want the larger of these two numbers to be negative. And here's two numbers that multiply together to give me negative 45, but they do not add together to give me a negative 4. Alright, so what about a negative 15 times a positive 3? That multiplies together to get negative 45, but unfortunately, negative 5 plus 3 does not add together to give me negative 4. So I try another combination. Maybe I try negative 9 and 5. That's negative 45. And a negative 9 plus 5 is a negative 4. So I have found it. This is the right combination with multiplication and addition that completes my x. So I come in and say that I can write negative 9x and positive 5x. Alright. Now, the true advantage of this x method is really when the leading coefficient, when the number in front of here is different than 1. That's when this table that we're going to make really pays off. But right now, some of you can get away with not making this table. And I'll tell you why here in just a second. Along one diagonal of the table goes our first term and our last term, the x squared and the minus 45x. oops, I'm sorry, minus 45. And along the other diagonal is the two numbers that we found in the x. And it doesn't matter whether I write the negative 9x here or here. I can swap these diagonals together. All right, so now let's look and see what divides both of these numbers. Well, negative 9 does. What divides both of these values? Well, positive 5 does. And a negative 9 times a positive 5 is negative 45. We don't see a number that divides 1 and 5, but we do see that the variable x does. It divides each of those terms. And vertically here, we see that an x also. So let's check our table. X times x is 1x squared. X times 5 is 5x. Negative 9 times x is negative 9x. And negative 9 times positive 5 is negative 45. So we know that this denominator factors to x minus 9 and x plus 5. So everywhere we see this trinomial, we can replace it with this product of two binomials. So let's move this out of our way. So let's come in and begin by trying to factor these other binomials, knowing that in the denominator right here, we have this x minus 9 times x plus 5, that we already did that scratch work, and that we already determined that what I've highlighted in yellow here is equivalent to this product of two binomials. We know it's the same from the table there. Alright, now this 18 minus 6x, is there a number that divides both of those terms? Can we rewrite 18? Well, we can. We can rewrite 18 as 6 times 3, and then we notice that a 6 is common to both terms. That here we have a 6, and in this term we have a 6. So we can remove the same factor from each term. I can remove this 6, I can remove this 6 if I make parentheses and I write that 6 out in front, because we have a property that's called the distributive property, that when you multiply these terms, that multiplication, they say, distributes over addition or subtraction. So 6 times 3 is 18, but then because of this property, I can jump over that subtraction and multiply 6 times x, and I get 6x. So we can rewrite this 18 minus 6x, we can rewrite this binomial as that product. And now we want to repeat that idea for these other two binomials. This 8x squared, I need to look at it as 8x times x. And I need to look at this 40x as 8x times 5, because 8 times 5 is 40. And I recognize that an 8x is common to both terms. So if I remove that 8x from each term, if this 8x is removed, I have to remove this, and then I write that 8x out in front. Let's kind of squeeze this together if we can. I don't know if it'll let me. Alright, let's keep trying. There we go. And then let's see if it'll... There we go. Okay, so let's check this. If we distribute, if 8x times x, yes, that's 8x squared, because x times x is x squared. The multiplication distributes over the addition, and 8 times 5 is 40 times the x. Alright, so we have factored this binomial. We have factored this binomial to be this product. So now we have one last binomial to do the same idea with. 24x squared and 72x. Is there a number that divides both of these? Yes, we can rewrite 24x squared as 24x times x. And this 72 x, we can rewrite it as 24x times 3. So we see that a 24x and a 24x is common to both terms. We can remove that common factor if we write that common factor as multiplication in front of this binomial. Now, just for ease of reading, we'll squeeze this together a little bit. That's the nice thing about this tablet, is I can illustrate things and move that together for you. Alright, so now let's look and see. Let's see, can I remove these highlighted things to get out of our way? No, apparently I can't. Try again. Yeah. Alright, I'm getting lucky here. Okay. So do we see things that cancel, that divide to 1? Well, this number x plus 5 divided by this number, since this is all multiplication, I have this in parentheses, let's even put the 6 in parentheses, then these numbers divide to 1. Because this is all multiplication. We're multiplying these things that are inside the parentheses times the other things inside the parentheses. Now, I have an x divided by an x. Well, we can do better than that. We know these x's cancel, and this 8x, that goes into itself once, and 8 goes into 24 3 times. Alright. And look here, 6 divided by 3. 6 divided by 3 is 2, so I put the 2 in the numerator. And from our discussion at the beginning of the video, 3 minus x and x minus 3 are opposites of each other. They don't divide to 1, but they divide to negative 1. So this x minus 3 and 3 minus x are negative 1. So hopefully that wasn't too much cancellations going on at the same time for you. In the numerator, we have a positive 2 times a negative 1 times a positive 1 times a positive 1. We get a negative 2. In the denominator, here I didn't write a 1 here, we have 1 times 1 times 1 times this x minus 9. So that's x minus 9. Now I don't know, I believe that that's how they'll write the answer. It's possible they could put that negative sign down in the denominator, or even use that negative sign to change the order of that subtraction. I'm going to leave this as my final answer. Let's go check and see. Hopefully it'll match up. Yeah. So I put my negative up in the numerator. They put it out in front of the fraction, which is the same thing. So I guess we can talk about that. When you have a negative sign in a fraction, you have one of 3 places that you can put it. You can put it in the numerator, or you could put it in the denominator, or you can just put it out in front of the fraction bar, which is what they did. All of these say the same thing. The negative 2 divided by x minus 9, the positive 2 divided by the opposite of x minus 9, or take the opposite of 2 divided by x minus 9. Alright, so let's take a look at this guy. We have the multiplication of 2 fractions, so we can multiply these numerators together and multiply these denominators together, and we can view this as a single fraction. So we don't have any trinomials, any 3 terms, so we don't have to do the x method, but we do want to factor these binomials. We want to look at 4x squared and 16x and see if there's a number that divides each term. So we need to think about 4x squared as 4x times x. And we need to think about 16x as 4x times 4. And recognize that we have 4x that's in this term and a 4x that's in this term. 4x is common to both terms, so we can factor that 4x out of this binomial. So when we do that, we remove the 4x from this term and we remove the 4x from the second term. That leaves us with that binomial of x plus 4. Now, we didn't actually, when I say removed it, we're actually moving it rather than removing it. We're moving it to the outside of this binomial. And now by the distributive property, 4x times x is 4x squared. The multiplication distributes over the addition, and 4x times 4 is 16x. So I haven't made any kind of a mistake because that the distributive property allows me to rewrite it like this. Now I want to do the same thing with this second term. I want to rewrite 14. 14 can be rewritten as 7 times 2. So I see that this first term has a factor of 7 and the second term has a factor of 7. These 7s are common to both terms, so we refer to that as a common factor. And we can remove that common factor from each term if we write it as multiplication in front of this binomial. I don't know if it's going to, well, it's not going to let me move this closer together, but that's fine. Alright, so now let's do the same thing in the denominator. We need to look at the 7x plus 70 and rewrite 70 as 7 times 10. And recognize that in this first term we have a factor of 7. In the second term we have a factor of 7 because factor is multiplication. And so we have a common factor to each term. We can remove that common factor from each term if we write this out in front of this binomial as multiplication. And I can check it. 7 times x is 7x, and 7 times 10 is 70. And again, we can do the same thing to this other binomial. We can rewrite 4x squared as 4x times x, and we can rewrite 16x as 4x times 4. And we see that 4x and 4x are common to both terms. So we can remove what's common to both terms if we write that common factor out in front of the binomial. So we can write a 4x out here if we have factored 4x from both terms. 4x times x is 4x squared. 4x times 4 is 16x. So now I've written this in factors, and hopefully some of these factors are going to cancel. Let's look and see. I see a 4x divided by a 4x gives me 1. I see an x plus 4 divided by an x plus 4 gives me 1. And I see a 7 divided by a 7 gives me 1. Now, the x minus 2, I don't see an x minus 2 down here. And I can't come in and cancel the individual terms. So in my numerator, what I have left is x minus 10. Because times 1 times 1 times 1, when you take 1 times x minus 2, you get x minus, did I say x minus 10 before? X minus 2. Now x plus 10 times all these 1s is x plus 10. Like I say, these are terms and these x's don't cancel because it's not multiplication. It isn't x times 2. It isn't x times 10. Then these x's would cancel and the 2 over 10 would reduce to 1/5. But it's not multiplication, it's subtraction and addition. So there's our final answer. We can't reduce this any further. Let's go check our answer with number 6, x minus 2 over x plus 10 against our key, x minus 2 over x plus 10. So far so good, we're doing okay. Now the problem has changed. We have a division. Now that's not an addition symbol, that's a division symbol. It is hard to read, and I'll make sure that on the quiz it's a little bit easier to read. So before I try to cancel anything, I have to change this multiplication or division to multiplication. Well, how do I do that? I can't just come in and change the problem, but we can change it to multiplication if division is the same as multiplying by the reciprocal. We can flip this fraction. We can write this as 9 over 8x. So it's a good thing that we didn't try to cancel these 9's out, because look, it's really multiplying the 9's together. Now, normally, when I'm multiplying fractions together, I multiply across the numerator and across the denominator. But oftentimes, if I can see a way to make the numbers reduce and make an easier multiplication, I try to do that. And isn't it true that 9 divided by 3 is 3? 3 goes into 3 once, and 3 goes into 9 3 times. If you need to see, what I'm doing is rewriting the number 9 as 3 times 3. And then I'm just canceling that 3 divided by 3 is 1. So I still have this 3 that's in the numerator. So 3 times 9 is 27. And x times x is x squared. And 27 and 8 do not share any common factors. You can write 27 as 3 times 3 times 3. You can write 8 as 2 times 2 times 2. They don't share anything that's going to cancel each other. So this is our final answer. Let's go check it against our key. (27 over 8x squared). So we're still doing okay. Alright, so again I have a division problem. So I don't want to jump in and start canceling things yet. I want to rewrite this problem as multiplication. So this 5x to the fourth, it gets multiplied by that denominator, 2x. And this 2, it moves to the denominator here. Now, I multiply straight across, but before I do that, I notice that I can reduce, rather than getting this 10 over 4 and then trying to reduce it, why not just say 2 divided by 2 is 1 and reduce it now. Alright, so 5 times 1 is 5, and x to the fourth times x is x to the fifth. And 2 times 1 is 2. So there's my final answer for number 8. 5x to the fifth over 2. Let's go check it. 5x to the fifth over 2. So we're doing alright. We've only got a few more to go. Now this one is a little bit longer. Alright. So I'm going to put parentheses around these binomials and around this 8. And I'm going to rewrite this division as multiplication. So the first fraction, be careful, don't flip it. It stays the same. And I have this x minus 5. Now this x minus 5 moves up to the numerator. And this numerator is now in the denominator. Alright, so now let's look and see if we can reduce things. And it sure looks like we can. That we have an x plus 1 divided by an x plus 1 that's giving us 1. And we have an x minus 5 divided by an x minus 5 that's giving us 1. So our numerator, 8 times 1 times 1 is just 8. And our denominator, 1 times x minus 5. And there is our final answer. Now I didn't need to draw that division bar that long. Alright, so there we have our answer for number 9. Let's check it against our key. 8 over x minus 5. Alright, so let's move over to number 10. And again, it's a division problem. So again, I'm not going to jump in and start canceling things yet. I'm going to I can write this as a single fraction. I'll leave the first fraction alone, and the factors that are in the denominator are now moved to the numerator. This x plus 8 times x minus 10. You see, this was in the denominator, and now it's in the numerator. And I do the same thing. The numerator now switches down to the denominator. And now I can look and see, are there any common factors that divide to 1? And there are. X minus 8, we don't have another x minus 8, but x minus 5 divided by x minus 5 gives me a 1. And an x plus 8 divided by an x plus 8 also gives me a 1. And wow, look at this. An x minus 10 divided by an x minus 10 also gives me a 1. I'm the world's fastest at multiplying by 1. The x minus 8 times 1, hey, x minus 8. And divided by 1, I don't have to write divided by 1. I can leave my answer as x minus 8. Let's go check that against our key. And we've got x minus 8. We've got 2 more to go. So I leave my first fraction alone, x squared minus 9x plus 8 over 6x minus 6, and this denominator now moves up to the numerator. X squared minus 5x plus 4, and what was in the numerator is now moved to the denominator. X squared minus 9x plus 8. Alright, let's get these highlighted things out of our way so that we can read this a little bit easier. Or at least I've been told by a few of you that it's easier to read if we remove those highlighters. This number, x squared minus 9x plus 8, see, that whole thing is a number, and x squared minus 9x plus 8 is the same number in the denominator. This number divided by that number is 1. So before we jump in and say that x squared minus 5x plus 4 over 6x minus 6 is our final answer, we have to see if that fraction would reduce. This trinomial, x squared minus 5x plus 5, we need to do the x method. So this middle term, negative 5x, and on top of the x, my 1x squared times 4, I need to come up with two numbers when multiplied together give me this positive 4x squared, and when added give me this negative 5x. So, well, with the 4, I can either have negative 2 times a negative 2 that gets me a positive 4, or a negative 4 times a negative 1 gets me a positive 4. But these numbers have to add up to negative 5. This adds up to negative 4. These add up to negative 5. So that's what I want. I want this minus 4x and minus 1x for my x method. Now, the true advantage of making a table is when that leading coefficient is a number that's big, that's bigger than 1. But out of habit, good habit, and practice, we'll go ahead and make our table. Our first term and our last term, x squared and 4. And along the other diagonal, we use the results that we found in the x method. We've got this negative 4x and negative 1x. Now, when this diagonal is negative and this corner is positive, when we factor, when we come up with a number that divides both of these, we have to make it negative. And here, these are relatively prime, but we make it a negative 1. Now, a negative 4 times a negative 1 is a positive 4. And these signs are going to help me here when I will look to see what's common. I have an x. And here when I look to see what's common, I have an x. So the x times x gives me x squared, and that negative 1 times x does get me the negative 1x, and negative 4 times x, negative 4x. And we already said a negative times a negative was a positive. So this x minus 4 on the side of the table and this x minus 1 along the top of the table allows us to say that this trinomial, by using the x method, factors to this. They look different, but they're the same thing. We can replace what I've highlighted there with each other. So in my numerator I have this 1 times this trinomial, but I know by the x method this trinomial is the same thing as x minus 4 times x minus 1. Now, I don't have an x method that I don't want to try it. It's easier on this binomial. I look and say, well, what's common to both of these? And I see a 6 is common to both of these. So, if you have 6x minus 6 times 1, then we have a 6 that appears in this term and a 6 that appears in that term. If we remove both of those 6's, that's what's common to both terms. That's the greatest common factor. Then we write that 6 out in front of this binomial. Okay? So when we look at this fraction, we see that we've got x minus 1 divided by an x minus 1, which just gives us 1. And in the numerator, we have x minus 4. And in the denominator, we have a 6. Now, even though these are both even numbers, we can't cancel terms. If it was 4 times x, then yes, we could, or x times 4, but it's subtraction. So this is our final answer for problem number 11. X minus 4 over 6. So our last problem, we're hoping to get 2x squared. Let's go see what we get. Alright, I do not have any trinomials, and it's division again. So my first step is an easy first step if you remember it. And that's to flip this second fraction. And then we can just multiply the numerators and denominators together. So what was on the bottom here, we write on the top. 6x squared plus 6x squared plus 21x. And what's in the numerator is now in the denominator. Alright, so now we need to see, well, does anything cancel here? And boy, we sure see that something cancels, so it'll save us a little bit of time. We don't have to try to factor it. We could reduce it, but why? You know, we can see that it's going to reduce, or I hope you can see it, that I have the number 6x squared plus 21x divided by that same number. They divide to 1. Now, I can't look at this 2x cubed plus 18x squared right now and see if it has a factor of x plus 9. But I suspect it might. You know, if not, that'll be our final answer. But let's look and see. Can we rewrite these in such a way that we can identify what's common to both terms? Well, we have an x squared here, so I can rewrite the x cubed as x squared times x. And I can rewrite the 18, 9 times 2, so I've got 2x squared, and then I have to multiply it by 9 to get the 18. So I can see that yes, I have a 2x squared and a 2x squared that's common to both of these terms. So I can remove that common factor and write it out in front as multiplication. This 2x squared is written out in front as multiplication. Now let's distribute it to check. 2x squared times x is 2x to the third power because 2 plus 1 is 3. And 2x squared times 9 is 18x squared. 2 times 9 is 18. Alright, now in the denominator, we have x plus 9. Hey, we were hoping that would happen, because now x plus 9 divided by x plus 9 is just 1. And we normally don't, our denominator being 1, we normally just don't write the denominator 1, and we've got 2x squared, which we knew was going to be the answer if you look back at that key. So I hope this helps. I've had trouble with these videos. This is the second or third video I've made, so hopefully this one took. I will talk to you later.